What if everything we know about human history is just the final chapter of a much longer story? What if the moment we learned to write wasn't when memory began, but when we stopped forgetting? Beneath the foundations of every ancient temple, below the oldest cities we dare to call civilization, something older waits in the dark, not buried by time alone, but by catastrophe, by intention, by silence that tastes like loss. 100,000 years ago, the earth turned beneath skies we would barely recognize. Ice sheets carved continents into shapes our maps have forgotten. Coastlines stretched hundreds of miles beyond where oceans lap today. And in that world, colder, stranger, achingly vast, something was happening that history refuses to acknowledge. Because 100,000 years ago, we are told, humanity was primitive. Small bands of hunter-gatherers scraping survival from stone and fire. No cities, no writing, no art. Just the slow, patient climb toward consciousness that wouldn't bloom for another 90,000 years. But the evidence whispers otherwise. In South Africa, ochre mines tunnel deep into bedrock show organized labor and abstract thinking. In Israel, shells pierced for jewelry traveled hundreds of miles from their ocean origins, suggesting trade networks, symbolic thought, and something we hesitate to name, culture. In Siberia, tools appear that required multi-step planning, foresight that reaches across seasons, and scattered across 3 continents, fragments of structures, alignments, and technologies that shouldn't exist yet. They don't fit the timeline we've been taught. They don't fit the story of gradual progress, the comforting arc from darkness to light. Instead, they suggest something far more unsettling, that civilizations may have risen and fallen long before we began counting time. Before we drift too far into these forgotten ruins, take a moment to like this video and subscribe, but only if you're drawn to mysteries that live between archaeology and myth. And if you're still here, leave a comment telling me where you're watching from and what hour you're keeping. I'd like to imagine this story unfolding across time zones, whispered softly into sleep, carried through the dark hours when the world feels oldest. Imagine standing on the shore of an ancient sea that no longer exists. The air tastes different, colder, thick with salt and distance. In the dim light before dawn, you see them. Stone markers arranged in patterns too deliberate to be natural. Structures that align with stars whose names we've lost. Technologies carved into rock, weathered by rain that fell when mammoths still walk the tundra. This isn't fantasy. These things exist. They've been photographed, measured, carbon dated, and then quietly filed away because they don't match the narrative. Because accepting them means rewriting everything we think we know about who we were and what we've forgotten. The journey ahead takes us into that forgotten world. We'll walk among impossible architectures that predate the pyramids by tens of thousands of years. We'll trace genetic whispers that suggest ancient populations possessed knowledge that vanished without explanation. We'll examine technologies that shouldn't exist in the hands of people we're told were barely human. And we'll ask the question that haunts every honest look at our deepest past. What happened to the world that died 100,000 years ago? Because something did happen, something vast enough to erase cities, languages, entire ways of seeing, something that reset humanity to its knees and forced us to begin again. The evidence is there, patient and silent, waiting in stone and bone, and the strange geometry of ruins that refuse to make sense. History, we're told, began 5,000 years ago, but memory, true memory, reaches back much further. And if we're brave enough to listen, the stones still remember everything. Close your eyes for a moment and imagine Earth 100,000 years ago, not as a slight variation of today's world, but as something profoundly alien, a planet you would barely recognize. The continents weren't where they are now, not dramatically shifted but different enough. Britain was not an island. It was connected to Europe by a vast grassland called Doggerland, where rivers flowed and forests grew over what is now the cold floor of the North Sea. Indonesia was not an archipelago of thousands of scattered islands, but a continuous landmass called Sunderland, stretching from mainland Asia to Borneo, Java, and Sumatra. A territory larger than India, entirely above water, with its own mountains, river systems, and ecosystems. Gone now, drowned. Between Asia and North America, a land bridge 1,000 miles wide connected the continents. Beringia, not a narrow corridor, but a subcontinent unto itself, with its own climate, its own wildlife, its own story. And in the Mediterranean, sea levels were so low that you could walk from North Africa to Sicily, from Greece to Turkey, without ever getting your feet wet. The world was bigger then, not in size but in accessible land. Sea levels were 400 feet lower than today, perhaps more during the coldest phases. That means coastlines extended for miles, sometimes hundreds of miles beyond where they are now. Entire continental shelves, now submerged beneath cold ocean currents, were dry land, fertile, habitable, populated. And then they were swallowed. Slowly at first, then catastrophically, taking with them everything that had been built, lived, and remembered there. Because here is what we forget when we imagine deep history. We think of ancient humans living inland, in caves, on mountaintops, in the deserts and savannas we can still excavate today. But humans, like all civilizations since, are drawn to water. Rivers, lakes, coastlines, the most fertile land, the easiest trade routes, the richest fishing grounds, all of it existed where the ocean now rolls. If there were cities 100,000 years ago, if there were settlements, ports, centers of knowledge, they would have been built exactly where we can no longer look. Beneath 400 feet of seawater, buried under millennia of silt and sediment, invisible to archaeology, erased from memory. The climate itself was a puzzle humanity had to solve generation after generation. 100,000 years ago, Earth was descending into the last glacial period, a phase of the Ice Age that would grip the planet for tens of thousands of years. But it wasn't a steady freeze. The climate oscillated wildly. Warm periods called interglacials would last for centuries, thawing the ice, raising sea levels, turning tundra into forest. Then the cold would return. Glaciers would advance, mile-thick sheets of ice grinding across North America, Europe, and Asia, locking water into frozen mass and draining the oceans lower and lower. Each cycle reshaped the world. Rivers changed course. Lakes dried up. Forests became grasslands. Grasslands became deserts. Deserts became tundra. Nothing stayed the same long enough to be permanent. To survive this, you couldn't just be adaptable. You had to be resilient on a civilizational level. You had to remember what plants grow when the rains return, where the herds migrate when the ice advances, how to read the stars when the landscape itself becomes unrecognizable. This wasn't primitive survival. This was applied environmental science passed down across generations, encoded in story, ritual, and practice. And if some populations succeeded better than others, if some groups developed systems, structures, ways of organizing knowledge that allowed them to thrive, how would we know? What would be left after the ice came back? And then there were the animals, creatures so strange, so massive, that if we only had their bones without context, we might think them mythological. The planet was ruled by megafauna. Woolly mammoths, 13 feet tall at the shoulder, covered in thick fur, roaming the grasslands of Europe, Asia, and North America in herds that stretched to the horizon. Mastodons, slightly smaller but equally powerful, browsing forests that no longer exist. Giant ground sloths, some as tall as elephants, weighing over 4 tons, moving slowly through the woodlands of South America. Saber-toothed cats, not lions, something else entirely, with canines 7 inches long, designed to puncture the thick hides of prey we've never seen alive. In Australia, the continent was stalked by the megalania, a monitor lizard 20 feet long, weighing half a ton, venomous and capable of taking down prey much larger than itself. Diprotodons, giant wombat-like marsupials the size of rhinos, grazed across landscapes that would later become desert. In Eurasia, cave bears, twice the size of modern grizzlies, dominated the northern forests. Woolly rhinoceroses, giant elk with antlers spanning 12 feet, short-faced bears that stood 12 feet tall on their hind legs and could run faster than a horse. These were not distant, rare creatures. They were everywhere. They shaped the environment. They were apex predators, ecological engineers, the dominant life forms on a planet that belonged to them, not us. And humans? Humans were small, fast, clever, but far from dominant. To hunt a mammoth wasn't just dangerous. It required coordination, planning, tools, language, strategy. It required a level of social complexity that goes far beyond what we typically associate with primitive hunter-gatherers. Some researchers now believe that hunting megafauna may have been the evolutionary pressure that drove the development of abstract thinking, symbolic communication, and long-term planning. Not farming, not cities, but the need to kill something vastly more powerful than yourself without getting killed in the process. That's what sharpened the human mind. But here's what makes it stranger. Humans weren't alone, not in the species sense. 100,000 years ago, Earth was populated by multiple human species. Homo sapiens, yes, anatomically modern, tool-using, language-speaking, already capable of symbolic thought. But also Neanderthals, thriving across Europe and Western Asia, stronger than sapiens, with larger brains, evidence of art, burial rituals, and tool technology that in some cases exceeded our own. And Denisovans, known only from fragments of bone and teeth found in a single cave in Siberia, but whose DNA tells us they ranged across Asia, interbred with sapiens, and contributed genetic adaptations that still exist in modern Tibetans and Melanesians. Denisovans gave us the ability to survive at high altitudes. That's not a minor contribution. That's biological engineering embedded in our genome. And there were likely others. Homo erectus may have still existed in isolated pockets of Asia. Homo floresiensis, the so-called hobbit species, survived on the island of Flores in Indonesia until at least 50,000 years ago, possibly longer. Some researchers suspect there are other species we haven't identified yet. Ghosts in the genome, DNA sequences that don't match any known hominin, suggesting interbreeding with populations we've never found fossils of. Species that lived, loved, fought, and vanished, leaving only genetic echoes. This wasn't a world with one human story. It was a world with many, running parallel, intersecting, diverging. Different species with different cultures, different technologies, different ways of seeing the world. What did Neanderthals believe? What stories did Denisovans tell their children? Did they have language, art, religion. We may never know, but the existence of burial sites, pigment use, and symbolic artifacts suggests they were not mindless brutes. They were human in ways we're only beginning to understand. Even the sky was different. Because of axial precession, the wobble in Earth's rotation that takes 26,000 years to complete, the stars occupied different positions. Polaris was not the North Star. The constellations we know didn't exist in the same configurations. If ancient humans watched the heavens, and we know they did, the stories they told, the patterns they saw, the meanings they encoded, were not the same as ours. The cosmos itself was telling a different story. And if you were an astronomer 100,000 years ago, tracking the stars across generations, you would have noticed something profound. The stars move, slowly, imperceptibly, but they move. Over lifetimes, the pole star shifts. Over millennia, the constellations drift. To observe this requires continuity, record-keeping, a system of knowledge passed down and refined over thousands of years. Could humans have done that? Mainstream archaeology says no. 100,000 years ago, humans were hunter-gatherers, mobile, opportunistic, living in small bands. No cities, no agriculture, no permanent settlements. The cognitive revolution that supposedly gave rise to art, religion, and complex society didn't happen until 70,000 years ago. Civilization didn't emerge until 10,000 years ago in Mesopotamia. That's the standard model. And yet, there are anomalies, objects, sites, and evidence that don't fit. In 1960, archaeologists in South Africa discovered the Lebombo bone, a baboon fibula with 29 deliberate notches carved into it, dated to 44,000 years ago, a tally stick, a lunar calendar, evidence of mathematical thinking, symbolic notation, long-term tracking of celestial cycles. Then in 1990, another bone, the Ishango bone from the Congo, dated to 25,000 years ago, covered in markings that some researchers believe represent prime numbers, not decoration, calculation, and these are just the objects that survived. Bone, stone, inorganic materials that can last tens of thousands of years. What about wood, rope, leather, textiles? Organic materials decay within centuries, sometimes decades. Entire technologies could have existed and left no trace. In Göbekli Tepe, Turkey, we found stone temples dated to 11,600 years ago. Massive, intricately carved pillars arranged in circles, depicting animals, symbols, and abstract patterns. It predates agriculture. It predates pottery. It predates permanent settlements. According to the old timeline, it shouldn't exist, and yet it does. And it's not crude. It's not primitive. It's sophisticated, planned. The work of an organized society with specialized labor, shared belief systems, and knowledge of astronomy. The pillars are aligned to celestial events. The carvings depict constellations. Whoever built Göbekli Tepe was not stumbling into civilization. They were already there. If that's possible 11,600 years ago, why not earlier? Why not 20,000 years ago? 50,000? 100,000? The only honest answer is, we don't know. Because we're not looking in the right places. We're looking inland, in caves, in places where stone survives. We're not looking under the ocean. We're not excavating the submerged coastlines where humanity actually lived. We're building our entire understanding of human history on the fragments that happened to survive in the least likely places. And there's another problem: catastrophism. For most of the 20th century, archaeology operated under uniformitarianism, the idea that Earth's history is shaped by slow, gradual processes. No sudden cataclysms, no global floods, no rapid shifts. But we now know that's wrong. The Younger Dryas, 12,800 years ago, saw global temperatures plummet in less than a decade. Sea levels rose 400 feet over several thousand years. Entire ecosystems collapsed. Megafauna went extinct. If civilizations existed before the Younger Dryas, they would have been obliterated, drowned, frozen, starved. And the survivors, they would have been thrown back into survival mode, forced to start over, carrying only memories, fragments, stories of a world that no longer existed. This is the world before. Not Eden, not primitive, not simple. A planet in flux, populated by giants, walked by multiple human species, shaped by climate chaos, and watched over by stars that told different stories than they do now. A world where knowledge had to be earned, preserved and transmitted across generations, or it would be lost forever. And perhaps in some places, some populations succeeded. Perhaps they built something. Not cities of steel and glass, but something. Centers of knowledge, astronomical observatories, trade networks, systems of communication that spanned continents. Perhaps they watched the stars, tracked the ice, mapped the coastlines, and passed it all down in ways we can no longer read. And then the ice came, the floods rose, the world ended. Not all at once, but enough. And what remained were stories, fragments, genetic echoes, and the haunting possibility that we are not the first to try. The earth keeps secrets in stone, in layers of sediment and limestone, in cuts that refuse to erode, in alignments that predate the civilizations we think invented them. And sometimes, when the wind scrapes away enough sand, or the tide pulls back far enough, those secrets surface, not as complete answers, but as fragments, impossible fragments that don't fit the timeline we've constructed. Fragments that whisper of something older. In 1991, archaeologists working in Blombos Cave on the southern coast of South Africa unearthed something that should not have existed. Ochre stones, etched with geometric patterns, crosshatched lines forming deliberate, repeating designs. The marks were not random, they were intentional, mathematical, symbolic. Evidence of abstract thinking, of minds capable of representation, of communication through visual code. The stones were dated using optically stimulated luminescence and radiocarbon analysis. 100,000 years old, 100 millennia before Sumeria, before Göbekli Tepe, before the pyramids, before anything we call civilization, someone sat in that cave and carved meaning into stone. They mixed ochre with bone marrow and fat, creating a paint that has survived longer than empires. They shaped shell beads, drilled with precision, strung into ornaments. They created tools not just for survival, but for expression. This was not primitive scrawling. This was symbolic thinking, the cognitive architecture that underlies language, art, mathematics, and religion. Everything we call human culture begins here, in these cross-hatched stones, and yet mainstream archaeology treats it as an anomaly, an isolated spark that flickered and died, leaving no lineage. But what if it didn't die? What if it continued, developed, evolved through cycles of climate and cataclysm that we've only begun to understand? What if Blombos was not the beginning, but evidence of a beginning much further back, now lost beneath ice, water, and time? The question becomes sharper when you move forward to Göbekli Tepe. Southeastern Turkey, Şanlıurfa Province, 1994. German archaeologist Klaus Schmidt surveys a site locals have long known as Potbelly Hill, a gentle rise dotted with limestone fragments. Within months of excavation, the world's understanding of human history fractures. Göbekli Tepe is a temple complex. Massive T-shaped pillars, some weighing over 16 tons, arranged in circular formations, carved with intricate reliefs of animals, foxes, lions, scorpions, serpents, vultures, abstract symbols that seem to tell a story we can no longer read. The stones are not crude. They are sophisticated, precisely shaped, some of them decorated with high-relief carvings that required advanced sculpting techniques. And the site is dated to 9,600 BCE, 11,600 years ago. This makes it older than Stonehenge by 6,000 years, older than the pyramids by 7,000 years, older than pottery, older than writing, older than agriculture. According to the standard model of human development, the people who built Göbekli Tepe were hunter-gatherers, nomadic tribes, small bands, pre-civilization, and yet they quarried, transported, carved, and erected stones weighing tons, organized labor on a scale that requires social hierarchy, planning, resource management, and specialized skills. They created a site so large that after decades of excavation, archaeologists estimate less than 5% has been uncovered. The implications are staggering. If hunter-gatherers could do this 11,600 years ago, what were they capable of during earlier warm periods? The Eemian interglacial, 130,000 to 115,000 years ago, was warmer than today. Sea levels were higher. Ecosystems flourished. If humans with symbolic thinking existed then, and Blombos suggests they did, what structures might they have built? And where would those structures be now? Underwater, submerged beneath the ocean that rose 400 feet at the end of the last ice age, erasing coastlines, drowning river valleys, swallowing entire landscapes where humanity once thrived. And that's exactly where we've started finding them. Off the coast of Gujarat, India, in the Gulf of Khambat, sonar surveys in 2001 revealed something extraordinary. Geometric structures, straight lines, right angles, grid-like patterns stretching across the seabed at depths of 120 feet. Underwater remotely operated vehicles captured images of stone formations, what appeared to be foundations, walls, possibly even remnants of urban planning. Samples of wood and other organic material were dredged up and carbon dated. The results came back between 9,500 and 7,500 years old. This would make them contemporary with Göbekli Tepe, but built on a coastline that no longer exists, by a people who left no name, no written record, only stone shapes beneath the waves. Mainstream archaeologists remain skeptical. The formations, they argue, could be natural, geological anomalies, sediment patterns shaped by currents. But the symmetry is difficult to dismiss. Nature rarely creates right angles. It does not often arrange stones in parallel rows or carve channels that resemble streets. And Khambat is not alone. Off the coast of Yonaguni, Japan, divers in 1987 discovered a massive submerged structure. Terrace platforms, carved steps, straight edges, what appears to be a central plaza, all cut from solid rock. The formation descends in layers, like a ziggurat or pyramid, with angles that suggest intentional shaping. Some of the cuts are clean, geometric, too precise to easily attribute to erosion. The structure sits at depths consistent with sea levels from 10,000 to 12,000 years ago. Geologist Dr. Masaki Kimura, who has studied the site for decades, argues it is man-made. He points to tool marks, right-angle cuts, post holes, and a stone that appears to have been carved into the shape of a face. Skeptics counter that the rock is sandstone, which fractures along natural plains, and that tectonic activity in the region could create such formations. But sandstone does not fracture into staircases. It does not create L-shaped terraces or tunnel-like passages that run horizontally through the rock. The debate continues, but the site remains, silent and submerged, waiting for an explanation that satisfies both geology and archaeology. Then there is Cuba. In 2001, Advanced Digital Communications, a Canadian company conducting sonar surveys off the western tip of Cuba, detected something at a depth of 2,000 feet. Massive stones, symmetrically arranged, covering an area of several square kilometers. The sonar images showed what appeared to be pyramids, roads, and circular structures, geometric shapes inconsistent with natural geology. Subsequent robotic submersible footage captured blocks that seemed cut and placed, though the depth and pressure made detailed analysis nearly impossible. If the structures are man-made, they would have to predate the last ice age significantly, because the depth suggests they've been submerged for at least 50,000 years, possibly much longer. Mainstream archaeology dismissed the findings almost immediately. Too deep, too old, impossible. But the sonar data has never been refuted, only ignored. The site remains unexplored, too expensive, too controversial, too far outside the boundaries of acceptable inquiry. And so it waits, like so many others, at the edge of what we're willing to believe. The stones themselves refuse to cooperate with our timelines. In Pumapunku, Bolivia, scattered across a high-altitude plateau, lie blocks of andesite and diorite, some of the hardest stones on Earth, carved with such precision that they interlock without mortar. The surfaces are smooth, polished, the angles exact. The cuts include complex interlocking joints, H-blocks with recessed grooves, geometric perfection that suggests machining rather than chiseling. Andesite ranks 6.5 to 7 on the Mohs hardness scale. Copper and bronze tools, which the pre-Columbian cultures of the region are supposed to have used, rank far lower. They would not cut andesite. They would barely scratch it. To shape these stones would require tools as hard or harder than the stone itself, diamond-tipped saws, or high-speed abrasion techniques. Some researchers have suggested the use of sonic vibration or chemical softening, methods that sound more like science fiction than archaeology. And yet the stones exist. They are real. They are impossibly precise. And no one has a satisfactory explanation. The same mystery appears in Egypt. The granite coffer inside the king's chamber of the Great Pyramid is carved from a single block of red Aswan granite, one of the hardest stones in Egypt. The interior corners are perfectly square. The walls are smooth and parallel to within thousandths of an inch. This level of precision is difficult to achieve, even with modern CNC machines. The ancient Egyptians are supposed to have used copper tools and stone pounders. Experiments attempting to replicate the work using these methods have failed. The tools wear down too quickly. The precision cannot be maintained. The corners cannot be squared. And yet, the coffer exists, sitting in the Great Pyramid for millennia, a monument to a capability we cannot replicate with the technology we think they had. Egyptologist Christopher Dunn, an engineer by training, examined the coffer and the granite blocks of the pyramid itself and found saw marks, drill holes, and grooves that suggest the use of high-speed rotary tools. The marks are not tentative or crude. They are fast, efficient, industrial. Some of the drill cores extracted from granite show spiral grooves indicating a feed rate, the speed at which the drill penetrated the stone, far exceeding what bronze or copper could achieve. Dunn concluded that whoever carved these stones had access to advanced machining technology, not technology like the Egyptians are supposed to have had, technology like ours, or perhaps something we don't yet understand. And then there are the alignments. Göbekli Tepe's pillars are aligned to celestial events, marking solstices and equinoxes with precision that requires long-term astronomical observation. The site includes what appears to be a star map, carvings that some researchers believe depict constellations, possibly even a record of a comet impact around 10,950 BCE, an event that would have been visible across the northern hemisphere and could correspond with the Younger Dryas climate event, a sudden return to Ice Age conditions that lasted over 1,000 years. If this interpretation is correct, then Göbekli Tepe is not just a temple, it's a memorial, a warning carved in stone by people who watched the sky fall and wanted future generations to remember. The Great Pyramid of Giza is aligned to true north, with an accuracy of 3/60th of a single degree. This is more accurate than the Royal Observatory in Greenwich. It's more accurate than most modern buildings. Achieving this requires precise astronomical measurement, sophisticated mathematics, and instruments capable of tracking stellar or solar positions over extended periods. The pyramid's dimensions encode mathematical constants. The ratio of its perimeter to its height approximates TWOP, the same ratio as a circle's circumference to its radius. The structure sits at the exact center of the Earth's landmass, the point where the longest lines of latitude and longitude intersect when measured across all continents. This cannot be coincidence. It can only be the result of knowledge, advanced geographical and mathematical knowledge, knowledge the ancient Egyptians are not supposed to have had, unless they inherited it. The Sphinx crouches at the edge of the Giza Plateau, its gaze fixed on the eastern horizon, weathered and enigmatic. For decades, Egyptologists have dated it to around 2500 BCE, attributing its construction to Pharaoh Khafre of the 4th dynasty. But in the 1990s, geologist Dr. Robert Schoch examined the erosion patterns on the Sphinx and surrounding enclosure walls and reached a startling conclusion. The weathering was not caused by wind and sand. It was caused by water, deep vertical fissures, rounded edges, wave-like patterns, all characteristic of prolonged rainfall and water runoff. The problem is that Egypt has been arid for the past 5,000 years. The last time the region experienced rainfall heavy enough to cause such erosion was during the African humid period, which ended around 5,000 to 7,000 BCE, possibly earlier. If Schoch is correct, and multiple geologists have since supported his findings, then the Sphinx could be 9,000 to 12,000 years old, possibly older. This would place its construction in a time before pharaohs, before dynastic Egypt, before the civilization we credit with building it even existed. The face of the Sphinx, many researchers note, is disproportionately small compared to the body and shows evidence of recarving. Perhaps the original face was something else, something older, later modified by the Egyptians who found it, already ancient, already weathered, and claimed it as their own. Massive megalithic structures appear across the world, each one requiring a level of organization, labor coordination, and engineering knowledge that shouldn't exist in the eras they're attributed to. Sacsayhuaman in Peru, Baalbek in Lebanon, the temples of Malta, Karnak in France, Easter Island. All of them involve stones weighing tens, sometimes hundreds of tons, transported across difficult terrain, lifted into place, fitted with precision. At Baalbek, the Temple of Jupiter sits atop a foundation that includes 3 stones, each weighing approximately 800 tons. Nearby, still in the quarry, lies the stone of the pregnant woman, weighing an estimated 1,000 tons. Modern cranes can lift around 20,000 tons under ideal conditions, but they require infrastructure, steel cables, hydraulic systems, and stable ground. Moving a 1,000-ton stone using ropes and wooden rollers, as conventional archaeology suggests, would require thousands of workers, perfectly synchronized, on terrain that offers little leverage. And yet, the stone exists. It was moved, or nearly moved, by people who left no written record of how they did it. No blueprints, no technical manuals, only the stones themselves, mute and immovable, defying every explanation. What kind of society could organize such efforts? The standard narrative assumes gradual development, small tribes growing into chiefdoms, chiefdoms into states, each stage marked by incremental increases in complexity. But the megaliths suggest something different. They suggest that at certain points in history, human societies achieved levels of coordination and technical knowledge that were then lost, forgotten, or deliberately erased. They suggest that civilization is not a ladder we climb steadily, but a cycle we enter and exit, rising and falling with the climate, the resources, and the knowledge we manage to preserve. Göbekli Tepe required hundreds, possibly thousands of workers, all fed, housed, and organized over decades or longer. This implies surplus food production, but the site predates agriculture. It implies social hierarchy, but no evidence of kings or priests has been found. It implies motivation, collective belief, a shared purpose strong enough to justify the immense labor. What could drive pre-agricultural people to build a temple? Unless the temple came first, unless the gathering, the building, the shared ritual was what created society, not the other way around. Unless civilization was not born from farming and cities, but from memory, the need to preserve something sacred, something that had been lost and needed to be rebuilt. And then there is the technology gap, the sudden appearance of capabilities with no apparent learning curve. Bronze metallurgy doesn't emerge gradually in the archaeological record. It appears already optimized, alloys mixed with precision, tools cast with consistent quality. Writing systems, like cuneiform and hieroglyphics, emerge fully formed. No prototypes, no trial and error, just complete linguistic systems capable of recording everything from poetry to astronomy. The same with mathematics, the same with monumental architecture, the same with astronomical observation. It's as if entire knowledge systems were imported, transplanted from somewhere or someone else, and embedded into cultures that should have been starting from scratch. Perhaps they were starting from ruins, perhaps the survivors of an earlier world, a world drowned or frozen or shattered by cataclysm, carried with them enough knowledge to seed the next cycle, not enough to rebuild what was lost, but enough to begin again, to lay foundations, to carve warnings and wisdom into stone so that future generations would remember, or try to. The stones are still here, submerged, eroded, scattered, ignored, but here. They do not speak in words, but they speak. They tell us that precision existed before it should have. That organization existed before we think it could. That knowledge existed before we believe it was discovered. They tell us that humanity's story is longer, stranger, and more interrupted than we've been taught. That the world before the flood, before the ice, before the forgetting, was not a blank slate of primitives waiting for history to begin. It was something else, something we've barely begun to excavate, something that built in stone because stone survives. Stone remembers. And if we listen closely, if we stop insisting that history follow the timeline we've drawn for it, the stones will tell us what we've forgotten, that we were here before, that we built before, that we knew and lost, and are only now beginning to remember. The architecture is impossible only if we assume it's the first time it was built. But what if it's not the first time? What if every megalith, every alignment, every precision cut is an echo, a reconstruction, a copy of something older, something that existed in the world that died 100,000 years ago? The stones won't answer that question, but they won't stop asking it either. But knowledge is not only preserved in stone and clay. Sometimes it hides deeper, in spirals of molecules coiled inside every cell of your body, in genetic code that remembers what no living human witnessed, in chromosomes that carry the scars of extinction events that nearly erased us from existence. The stones may lie in ruins, the tablets may crumble to dust, but DNA does not forget. It archives catastrophe. It records the precise moment when humanity stood at the edge of oblivion and somehow, impossibly, survived. In 1987, a team of geneticists led by Rebecca Cann published a study that would rewrite human origins. By analyzing mitochondrial DNA, the genetic material passed exclusively through the maternal line. They traced every living human back to a single woman who lived in Africa approximately 150,000 to 200,000 years ago. She wasn't the only woman alive at the time. She wasn't even necessarily special. But she is the only woman from that era whose maternal lineage survived unbroken into the present. Every other line went extinct. The researchers called her mitochondrial Eve. And she revealed something unsettling. Humanity is far less diverse than it should be. Compare our genetic variation to chimpanzees. Chimps separated by a single river in Africa show more genetic diversity between their populations than all 8 billion humans alive today. We should be more varied. We should carry the accumulated mutations of hundreds of thousands of years of independent evolution across different continents. But we don't. Our DNA tells the story of a species that passed through a bottleneck, multiple bottlenecks, events so severe that they reduced our population to numbers small enough that genetic diversity collapsed. We are the descendants, not of a thriving species, but of survivors, scattered remnants, who carried forward only fragments of what had existed before. Then in 1997, geneticists identified Y-chromosomal Adam, the most recent common male ancestor of all living humans, through analysis of the Y chromosome passed from father to son. He lived roughly 200,000 to 300,000 years ago, and like mitochondrial Eve, he represents not the origin of humanity, but a genetic choke point, a moment when population crashed so severely that only certain lineages made it through. But here's what makes the data strange. The genetic evidence doesn't point to a single catastrophe. It points to multiple crashes, waves of near extinction that hammered humanity again and again, each time reducing our numbers, each time narrowing the thread by which our species clung to existence. Around 74,000 years ago, something happened that nearly ended us entirely. In Sumatra, the Toba supervolcano erupted with a force almost unimaginable. It ejected more than 2,800 cubic kilometers of ash and rock into the atmosphere. For comparison, the eruption of Mount St. Helens in 1980 ejected 1 cubic kilometer. Toba was nearly 3,000 times larger. The explosion was heard across the Indian Ocean. Ash layers from the eruption have been found in ice cores from Greenland, in sediment cores from the Indian Ocean, in geological strata across South Asia. The ashfall blanketed the Indian subcontinent in layers up to 6 meters deep, choking rivers, collapsing ecosystems, burying entire forests beneath volcanic debris. But the ash was only the beginning. The sulfur dioxide thrown into the stratosphere formed a veil that blocked sunlight for years. Global temperatures plummeted. Some estimates suggest a volcanic winter lasting 6 to 10 years, followed by a cooling period that persisted for 1,000 years. Plants died, herbivores starved, predators followed, and humanity, small bands of Homo sapiens scattered across Africa and possibly into the Near East, was pushed to the brink of extinction. Genetic studies estimate that the global human population may have dropped to as few as 3,000 to 10,000 individuals. Some models suggest even lower, 1,000 breeding pairs. That's it. The entire future of the species hanging by a thread so thin that a single disease, a single drought, a single stretch of bad winters could have snapped it entirely. And yet we survived. Not just survived, but emerged from that bottleneck with something new. Because the humans who came after Toba were different. The archaeological record shows a sudden flowering of symbolic behavior. Cave paintings, jewelry, sophisticated toolkits, ritual burials, evidence of abstract thought, planning, and cultural transmission, as though the catastrophe had forged something in us, as though the species that walked out of the volcanic winter was not the same species that walked into it. Evolutionary pressure in its rawest form, adapt or vanish, and somehow we adapted. But here is where the genetic data becomes truly strange. In 2010, scientists sequencing DNA from a 40,000-year-old fingerbone found in Denisova Cave in Siberia discovered something no one expected. The DNA didn't match Homo sapiens. It didn't match Neanderthals either. It belonged to a sister species, previously unknown, now called Denisovans. They were human, but not us. They had diverged from our lineage hundreds of thousands of years earlier, evolved in isolation, developed their own adaptations, and then disappeared from the fossil record, leaving almost no physical trace. We know them almost entirely through genetics, and the revelation didn't stop there. When researchers compared Denisovan DNA to modern human genomes, they found fragments. Living humans, particularly populations in Melanesia, Australia, and Southeast Asia, carry Denisovan DNA, between 3% and 6% of the genome in some groups, which means our ancestors didn't just encounter Denisovans. They interbred with them, and it wasn't just Denisovans. We carry Neanderthal DNA as well, roughly 1% to 2% in most non-African populations. Genetic evidence of interbreeding that occurred in the Near East and Europe between 50,000 and 60,000 years ago. But recent studies have revealed something even more puzzling. Ghost populations. Genetic signatures in modern African populations that don't match any known hominin species. DNA that suggests interbreeding with archaic humans we have never found. Species that left no fossils, no tools, no remains, only genetic echoes carried forward in our chromosomes. How many were there? How advanced were they? What knowledge did they possess that vanished when they did? Some of the Denisovan genes we carry are not random leftovers. They are adaptive, functional. Genes that help modern Tibetans survive at high altitudes by regulating oxygen intake. Genes that assist Inuit populations in metabolizing fat in Arctic diets. Genes that provided immunity to diseases our ancestors had never encountered before. These were not genetic accidents. They were survival tools. Denisovans had spent millennia adapting to environments we were only beginning to enter. And when we encountered them, We didn't just compete. We absorbed their adaptations. We took what worked and carried it forward. It suggests something remarkable, that interbreeding with other hominin species was not incidental, but strategic, that our ancestors recognized value in the genetics of these sister species and integrated them deliberately, or perhaps simply survived because they did. And there's more. In 2016, researchers analyzing the genomes of modern humans found evidence of a previously unknown hominin lineage that contributed DNA to West African populations. No fossils, no artifacts, just genetic whispers. This ghost population diverged from modern humans over 300,000 years ago and interbred with our ancestors within the last 30,000 years, long after we supposedly left Africa, long after we were supposed to be alone. It suggests that the story of human evolution is not a straight line from primitive to modern, but a tangled web of encounters, extinctions, and genetic exchange. A story in which multiple human species coexisted, competed, and combined in ways we're only beginning to understand. Then there is the mystery of the islands. Genetic studies of indigenous populations in Australia, Papua New Guinea, and remote Pacific islands reveal something that should not be possible given our understanding of ancient technology. Human DNA arrived on these landmasses far earlier than any known seafaring capability should allow. Aboriginal Australians have been genetically isolated for at least 50,000 years, possibly longer. That means their ancestors crossed open ocean from Southeast Asia to Australia during the last ice age. The sea levels were lower then, yes, the distances shorter, but even at the lowest point, reaching Australia required crossing at least 90 kilometres of open water. No land bridges, no island hopping, just open sea. How did they do it? We have no evidence of boats from that period, no preserved watercraft, no depictions of maritime technology. And yet the DNA proves it happened, not once, but repeatedly. Populations reached islands across the Pacific. They colonized, they survived, they diversified. Genetic data shows deliberate, sustained seafaring across distances that modern sailors would find daunting, even with navigational instruments. The ancestors of the Polynesians were crossing thousands of kilometers of ocean, navigating by stars, currents, and bird flight, settling islands invisible beyond the horizon. By 1500 BCE, humans had reached Fiji, Tonga, and Samoa. By 1000 CE, they had colonized Hawaii, Easter Island, and New Zealand. The so-called Polynesian Triangle, an area covering over 10 million square miles of ocean, all without compasses, without maps, without metal tools, just knowledge, passed down generation after generation, star paths, wave patterns, cloud formations, oral traditions encoding navigational data, too complex to be accidental. The genetics confirm it. Polynesian DNA traces back to Taiwan and coastal Southeast Asia, meaning these populations migrated eastward across the Pacific in one of the most extraordinary feats of exploration in human history. But here's the question. If they possess that level of knowledge, that degree of sophistication in understanding astronomy, oceanography, and environmental patterns, what else did they know? What other sciences did they carry with them, encoded not in writing, but in practice, in song, in ritual? And if that knowledge could survive for 50,000 years in oral form, what other knowledge might have existed before it? Knowledge held by populations that didn't survive, that left no descendants, that vanished in the bottlenecks and cataclysms, leaving only the faintest genetic traces. And then there is the brain itself. Modern human cognition, our capacity for abstract thought, Symbolic reasoning, language, and complex planning appears suddenly in the archaeological record. Not gradually, not incrementally, suddenly. Between 70,000 and 50,000 years ago, human behavior changes. Art appears. Ritual burials become common. Toolkits diversify and standardize. Long-distance trade networks emerge. Evidence of counting systems, calendrical awareness, and symbolic notation shows up on bones and cave walls. The change is so abrupt that some researchers call it the Great Leap Forward. But genetic studies suggest it wasn't a mutation. It wasn't a lucky evolutionary accident. It was environmental. The result of pressures so extreme that only those capable of abstract thought, cooperation, and innovation could survive. Toba may have been part of it. The volcanic winter would have rewarded planning, delayed gratification, and the ability to encode knowledge across generations. But there may have been other pressures, other catastrophes, other encounters with sister species that forced us to adapt or be replaced. Because the DNA shows something else. It shows that our brains didn't just grow, they reorganized. The regions responsible for language, for tool use, for social cognition, all show signs of rapid development in the last 100,000 years. Not the slow accumulation of mutations, but accelerated change, selection pressure in overdrive, as though survival itself demanded intelligence, as though the world was culling the species that couldn't think fast enough to adapt. And perhaps that's the real story the DNA is telling us. Not that we are the culmination of evolution, not that we are the inevitable result of progress, but that we are the remnant, the survivors of a gauntlet that eliminated everyone else. The Neanderthals, with their robust builds and cold-adapted physiology, gone. The Denisovans, with their high-altitude genes and mysterious range, extinct. The ghost populations of Africa, unnamed and unknown, erased. All of them possessed adaptations. All of them survived for hundreds of thousands of years, and all of them vanished. We remain not because we were superior, but because we were flexible, because we could interbreed, adapt, absorb, and remember. Because when the world collapsed, we carried forward the knowledge that mattered, not in books, not in monuments, but in our cells, in genetic code that remembers what no story could preserve. Mitochondrial Eve and Y-chromosomal Adam are not the beginning of humanity. They are the echoes of an ending, the genetic shadows of populations that perished, leaving only a thread of continuity thin enough to fit through the eye of extinction. And what the DNA suggests, hauntingly, persistently, is that it happened more than once. That humanity has died before. Not completely, but close enough. Close enough that everything was lost except the will to survive. And perhaps the faint genetic memory of what we once knew. But knowledge is not only preserved in stones and bones. Sometimes it hides in formulas, carved into monuments we thought were merely decorative, encoded in myths we dismissed as primitive fantasy, buried in artifacts so anomalous that museums keep them in back rooms, away from the tidy narratives of linear progress. Because if there is one pattern that emerges from the archaeological record, one thread that runs beneath every excavation, every translation, every carbon date that refuses to cooperate, it is this. Ancient peoples knew things they should not have known. Not primitive approximations, not lucky guesses, but precise, technical, sophisticated knowledge that would not be rediscovered for thousands of years, if ever. Take astronomy, the oldest science, the first language humanity learned to read, written not on clay or stone, but across the vast darkness of the heavens. We are told that systematic astronomy began with the Babylonians around 1800 BCE, that the Greeks refined it, that medieval Islamic scholars preserved it, and that European scientists finally perfected it during the Renaissance with telescopes and calculus. A neat progression, stone to bronze, to iron to enlightenment. Except the timeline keeps breaking. In 1929, historians examining the Palace Library of Topkapi in Istanbul discovered a map. Not just any map. The Piri Reis map, drawn in 1513 by an Ottoman admiral who claimed to have based it on older charts, some dating back to the time of Alexander the Great. The map shows the Atlantic coastline of South America with reasonable accuracy. Impressive, but not impossible for the age of exploration. But it also shows something else. The northern coast of Antarctica, in correct longitudinal position, without ice. Mainstream scholars were quick to dismiss it. A misinterpretation, they said. Antarctica wasn't discovered until 1820, and its true coastline beneath the ice sheets wasn't mapped until the 1950s using seismic surveys and radar. There was no way a 16th century admiral could have known what lay beneath miles of glacial ice, let alone cartographers from Alexander's era. And yet, when researchers compared the Piri Reis map to modern seismic data of Antarctica's subglacial bedrock, the correlation was undeniable. The bays, the river mouths, the coastal features matched. Not perfectly, but close enough to eliminate coincidence. The map depicted Antarctica as it would have appeared during the last ice age, when sea levels were lower and the northern coast was not yet buried beneath ice. Roughly 10,000 to 100,000 years ago. How? If the source maps were truly ancient, who drew them? Who possessed the technology to accurately survey and chart coastlines on a continental scale during an ice age? Who had the mathematical knowledge to project a spherical surface onto a flat plane, a technique that requires understanding spherical trigonometry and the curvature of the Earth? Piri Reis was not alone. The Orontius Phineas map of 1531 shows the entire Antarctic continent, accurately shaped with mountain ranges in the interior that weren't confirmed until the International Geophysical Year surveys of 1957 and 1958. The Boache map of 1737 shows Antarctica divided into two major landmasses, separated by a waterway. Modern seismic surveys confirm this. Beneath the ice, Antarctica is indeed two islands connected by frozen water. Philippe Boache, an 18th century French geographer, had no way of knowing this. He claimed he was copying from more ancient sources he could not identify or authenticate, sources that, according to the conventional timeline, should not exist. And then there is the astronomical knowledge itself, not just star charts, but calculations. In 1900, sponge divers off the coast of Antikythera, a small Greek island, discovered a shipwreck. Among the amphorae and statues, they found a corroded lump of bronze, fused together by centuries of salt and sediment. It sat in a museum for decades, catalogued as scrap, until someone looked closer. In the 1950s, when researchers finally X-rayed the object, they found gears, dozens of them, interlocking bronze gears, precisely cut, arranged in a complex mechanism of wheels, dials, and inscriptions. It was a machine, an analog computer designed to calculate the positions of the sun, moon, and planets. It tracked lunar phases. It predicted solar eclipses. It modeled the irregular orbit of the moon using an epicyclic gear system, a mathematical solution that wouldn't be rediscovered until the work of Johannes Kepler in the 17th century. The Antikythera mechanism, dated to around 100 BCE, is more sophisticated than any known device for the next 1,500 years. It represents a level of precision engineering, astronomical knowledge, and mathematical modeling that has no precedent in the historical record and no successor until the invention of European clockwork in the Renaissance. But here is the question no one wants to ask. If the Greeks of 100 BCE could build this, what did they inherit from the civilizations before them? What did the Minoans know? What did the Egyptians preserve? And if we go back further, to the cultures erased by the Younger Dryas floods, to the peoples who lived during the Ice Age, before the cataclysm, what technologies did they possess that left no trace except in the faint memory of successors who no longer understood what they were copying? Because the Antikythera mechanism did not emerge from a vacuum. Its sophistication implies generations of prior development, workshops full of craftsmen who understood gear ratios and differential systems, astronomers who had tracked the heavens for centuries. Yet we have no evidence of this progression. The mechanism appears like a fossil out of time, an artifact of a knowledge base that should not yet exist, or should no longer exist. And the Greeks were not the only ones. In ancient Egypt, surgeons performed trepanation, drilling holes into the skull to relieve pressure or treat injury. Skeletal remains show evidence of healed bone, proof that patients survived the procedure. This requires not just steady hands, but knowledge of antiseptics, anesthesia, and infection control. The Edwin Smith papyrus, dated to 1600 BCE, but believed to be a copy of a much older text, describes surgical techniques for setting fractures, suturing wounds, and treating brain injuries with a clinical precision that reads like a modern medical textbook. It lists 48 case studies. Each one follows the same format: title, examination, diagnosis, prognosis, treatment. No mysticism, no invocations to gods, just anatomy, symptomology, and procedure. The text distinguishes between ailments that can be treated, ailments that can be contended with, and ailments not to be treated, a triage system. It describes the brain as the organ of thought and movement, a fact that European medicine would not accept until the Renaissance. And it does all of this using terminology so technical that modern translators struggled for decades to find equivalent medical terms. Where did this knowledge come from? The Egyptians attributed it to Imhotep, the architect and physician deified after his death. But Imhotep himself, according to inscriptions, was not inventing medicine. He was preserving it, recording the practices of the ancestors, the healers who came before the dynasties, before the pyramids, before the flood. And it was not just surgery. Ancient peoples possessed pharmaceutical knowledge that seems impossibly advanced. The Ebers Papyrus, another Egyptian medical text, lists over 700 remedies using compounds like willow bark, which contains salicylic acid, the active ingredient in aspirin, poppy extracts for pain relief, honey as an antibacterial agent, mouldy bread applied to wounds, a primitive form of penicillin. These are not folk remedies stumbled upon by accident. These are targeted, specific applications of biochemistry, as though the principles of infection, inflammation, and pain management were already understood. In South America, evidence suggests that ancient Andean cultures performed successful blood transfusions and advanced orthopedic surgery, including the use of metal pins to set fractures. Skulls from the Paracas culture show survival rates for trepanation exceeding 80%, higher than some surgical success rates in 19th century Europe. How? What knowledge were they preserving? And then there is metallurgy. The conventional timeline tells us that metalworking evolved slowly. Native copper hammered cold, then smelting, then alloying, bronze, iron, steel, a stepwise progression spanning millennia. But artifacts keep appearing that do not fit. In 1936, German archaeologist Wilhelm König discovered a collection of clay jars near Baghdad, each containing a copper cylinder and an iron rod. When filled with acidic liquid, they generate electrical current. The Baghdad battery, dated to around 250 BCE, predates any supposed understanding of electrochemistry by 2,000 years. Some researchers argue it was used for electroplating gold, a technique that requires precise control of voltage and duration. Others dismiss it as a storage vessel for scrolls, but the design is unmistakable, and it was not unique. Similar objects have been found in Egypt. In India, the Iron Pillar of Delhi stands over 7 meters tall, weighing more than 6 tons, and has resisted rust for over 1,600 years, despite exposure to monsoons. Metallurgical analysis reveals an unusually high phosphorus content and an even distribution of slag particles, a composition that creates a protective layer against corrosion. Modern steelmakers only recently figured out how to replicate this effect, yet there it stands, forged in the 4th century CE using techniques no one recorded and no one remembers. The Incas built structures using bronze clamps to hold massive stone blocks together, despite having no written language and supposedly no knowledge of advanced metallurgy. The clamps were poured molten into carved channels, requiring temperatures exceeding 1,000 degrees Celsius and an understanding of thermal expansion. No, furnaces capable of achieving these temperatures have been found at the sites. But perhaps the strangest knowledge of all is acoustic. In the 1990s, researchers studying the treasury at Petra in Jordan discovered that the interior chamber resonates at a precise frequency when sound is introduced. The dimensions of the room, the angle of the walls, the height of the ceiling, all of it creates a standing wave at 111 Hz. This frequency has measurable effects on human neurochemistry, inducing altered states of consciousness, enhancing meditative focus, and triggering emotional responses. The same frequency has been found in passage chambers inside New Grange in Ireland, in the King's Chamber of the Great Pyramid, in temples at Hal Saflieni in Malta. These were not accidents. The builders understood resonance. They understood how sound moves through stone, how certain frequencies align with human physiology, how architecture could be used not just to enclose space, but to manipulate consciousness. Acoustic engineers today use computer models and advanced physics to design concert halls with this level of precision. Yet Stone Age builders achieved it with rock and intuition, or so we are told. But it was not intuition. It was knowledge, preserved, encoded, applied, and the mathematics, constants appearing in structures long before the math was supposedly invented. The Great Pyramid encodes pi in the ratio of its height to its base perimeter. It encodes phi, the golden ratio, in the slope of its faces. The perimeter of the base divided by twice the height equals pi to 4 decimal places. Coincidence, perhaps, except the same ratios appear in Stonehenge, in Teotihuacan, in Angkor Wat, separated by oceans and millennia, yet built using identical geometric principles. How much of this was transmitted orally? How much knowledge was preserved not in writing, but in stories, in songs, chants, myths that encoded formulas within narratives so they could survive when the cities fell and the libraries burned? The Aboriginal Australians have oral traditions stretching back tens of thousands of years, stories that describe the flooding of coastal plains, the formation of islands, events that geologists confirm occurred during the last ice age. The stories are not vague, They name specific landmarks, describe precise changes in geography, preserved across 400 generations without writing. Knowledge encoded in myth, hidden in plain sight. Perhaps that is the answer. Perhaps the ancient world did not lose its knowledge in a single cataclysm. Perhaps it was dispersed, fragmented, encoded into the only storage medium that could survive the collapse of civilization. Human memory. The bards, the shamans, the priests who memorized tens of thousands of lines, who passed down star charts disguised as genealogies, who preserved astronomical cycles in the names of gods and heroes. And perhaps what we call mythology is simply science we have forgotten how to read. The stories of gods descending from the heavens, not metaphor, but memory. The tales of great floods, not allegory, but archive. The legends of golden ages, not fantasy, but history. Because the one thing the evidence makes clear, whispered from every impossible artifact, every out-of-place formula, every map that should not exist, is this. They knew. The ancients knew far more than we give them credit for. And what they knew, they tried desperately to preserve. Not for themselves, but for us. The descendants. The survivors. The ones who would come after the world ended and wonder what had been lost. Something happened 12,800 years ago. Something that left scars in the Earth's crust, disrupted the climate, and sent sea levels rising by 400 feet. Something that appears in the geological record as a dark layer of sediment marked by materials that shouldn't exist together. Nanodiamonds, microspherules, iridium concentrations, shocked quartz, platinum anomalies, and a carbon-rich black mat containing the incinerated remains of entire ecosystems. This is not the signature of gradual change. This is the signature of impact. The Younger Dryas period, 12,800 to 11,600 years ago, represents one of the most dramatic climate reversals in Earth's recent history. The planet had been warming steadily, emerging from the last ice age. Ice sheets were retreating, forests were expanding, and then, abruptly, the warming stopped. Temperatures plummeted. Glaciers surged forward again. Megafauna, giant sloths, mammoths, saber-toothed cats, dire wolves, species that had survived hundreds of thousands of years of ice ages, suddenly went extinct. Across North America alone, 35 genera of large mammals disappeared within centuries. Not a slow decline, a collapse. For decades, scientists attributed this to overhunting by early humans or gradual climate shift. But the timeline didn't fit. The extinctions were too sudden, too synchronized across continents. And the climate reversal was too sharp, too severe to be explained by orbital mechanics or ocean currents alone. Then, in 2007, a team of researchers proposed something different. The Younger Dryas impact hypothesis. The theory that Earth had been struck, not by a single asteroid, but by fragments of a disintegrating comet, a cosmic shotgun blast that hit multiple locations across the northern hemisphere, triggering wildfires, atmospheric dust loading, and the rapid onset of an ice age that lasted more than 1,000 years. Mainstream science resisted this reading almost universally. The evidence, they argued, was inconclusive. Impact craters from that period were difficult to locate beneath ice sheets and ocean floors, but the markers kept appearing. At dozens of sites across 4 continents, researchers found the same anomalous layer, dated to precisely 12,800 years ago. Sediment cores. From Greenland, ice sheets showed platinum spikes 100 times normal levels. Soil samples from North America, Europe, and the Middle East contained microscopic diamonds that only form under extreme pressure and heat. the kind generated by hypervelocity impacts. Charcoal deposits suggested continent-wide wildfires, and buried beneath this black mat were the bones of extinct species, frozen mid-stride, as though the world had ended in an afternoon. The mathematics of the destruction are staggering. A fragmented comet entering Earth's atmosphere would release energy equivalent to millions of nuclear weapons. The airbursts alone would ignite forests across thousands of square miles. The thermal pulse would vaporize anything within line of sight. Shockwaves would flatten trees, level settlements, and trigger earthquakes along fault lines. If fragments struck ice sheets, the flash melting of glaciers would release catastrophic floods. Walls of water hundreds of feet high, carrying icebergs, boulders, and debris across the landscape, scouring everything in their path down to bedrock. And then the cold would come. Dust and aerosols ejected into the stratosphere would block sunlight for years, maybe decades. Temperatures would drop. Crops would fail. The hydrological cycle would stall. Rivers would freeze. And any civilization dependent on agriculture, on trade networks, on coastal settlements, would find itself suddenly, violently disconnected from the systems that sustained it. This is how worlds end. Not gradually, but all at once. But the comet theory is only one possibility. Earth's history is written in catastrophes, and the Younger Dryas is not the only candidate. Roughly 74,000 years ago, Mount Toba in Indonesia erupted with a force 5,000 times greater than the 1980 eruption of Mount St. Helens. It ejected 2,800 cubic kilometers of ash into the atmosphere, triggering a volcanic winter that lasted 6 to 10 years. Temperatures plummeted by 10 to 15 degrees Celsius. Ice cores from Greenland show sulfate spikes that suggest the eruption may have accelerated the onset of a millennium-long glacial period. Genetic studies indicate that the human population bottlenecked around this time, possibly collapsing to as few as 3,000 to 10,000 individuals. If an advanced civilization existed before Toba, it would have been erased, not just by the eruption itself, but by the collapse of the climate systems it triggered. The sky would have darkened. The sun would have become a pale disk behind a veil of ash. Photosynthesis would have slowed. Food chains would have collapsed from the bottom up. Survivors would have faced not just the immediate destruction, but years of cold, famine, and darkness. And this pattern repeats. Between 15,000 and 8,000 years ago, as the Ice Age ended, the planet experienced a series of catastrophic meltwater pulses. Meltwater Pulse 1A, dated to around 14,600 years ago, saw global sea levels rise by 16 to 25 meters, roughly 50 to 80 feet, in less than 500 years. Some models suggest the rise happened even faster, perhaps within a century. Meltwater Pulse 1B, around 11,400 years ago, near the end of the Younger Dryas, added another 15 meters. In total, between the peak of the last ice age and the onset of the Holocene, sea levels rose by approximately 120 meters, nearly 400 feet. Imagine what that means for coastal civilizations. Every port, every harbor, every city built along river deltas and shorelines drowned. The continental shelves, vast expanses of fertile lowland, where evidence suggests human populations may have concentrated, submerged beneath hundreds of feet of water. The Sunda Shelf in Southeast Asia, once a landmass the size of India connecting Malaysia, Indonesia, and Borneo, vanished beneath the sea. The North Sea, once a habitable plain where hunters tracked game and built settlements, became ocean. The Persian Gulf, the Black Sea, the Mediterranean basin, all transformed as rising waters redrew the map of the world. If advanced societies existed on these coasts, and there is every reason to believe they did, we would never find them. Their cities lie beneath continental shelves, buried under sediment, eroded by currents, inaccessible to all but the most sophisticated underwater archaeology. And even if we could reach them, what would remain? Wood rots, textiles dissolve, metals corrode. Stone might survive, but without context, without inscription, a single megalith on the seafloor is just geology, a curiosity, not proof. But the memory survives, because across every inhabited continent, separated by oceans and millennia, humanity tells the same story. The flood, not metaphorical, not symbolic. The flood. A deluge sent by the gods, or by nature, or by the breaking of the cosmic order. Water rising until it covered the mountains, cities swept away, humanity nearly extinguished, and a handful of survivors, chosen or lucky, who carried the knowledge of the old world into the new. The Epic of Gilgamesh, preserved in Sumerian and later Akkadian texts, describes Utnapishtim, who built a great boat to survive a flood sent by the gods to destroy humanity. The dimensions of the ark, the duration of the rains, the landing on a mountain, the sending of birds to find dry land, all of it detailed with the precision of memory, not myth. The Hebrew Bible recounts Noah, chosen to preserve life through the deluge, the waters rising for 40 days and 40 nights, covering the earth, erasing the wickedness of the antediluvian world. Hindu texts speak of Manu, warned by a great fish, later revealed to be Vishnu, who builds a ship and survives the flood that destroys all other life. Greek mythology preserves Deucalion and Pyrrha, who survive Zeus's flood in a chest and repopulate the earth by throwing stones that become people. The Aztecs recorded 4 previous worlds, each destroyed by catastrophe. The 4th world, the world of water, ended in a great flood that turned humans into fish. The Maya told of a deluge sent to cleanse the earth of imperfect creations. Inca legends describe Viracocha emerging from Lake Titicaca after a flood to remake the world. The Haida people of the Pacific Northwest speak of a time when the ocean rose and only those who fled to the mountaintops survived. Australian Aboriginal stories, some of the oldest continuous oral traditions on Earth, recall when the sea swallowed the land and the ancestors had to move inland. These are not coincidences. These are not independent inventions. This is cultural memory of real events, encoded in narrative, passed down through generations because the alternative was to forget, and to forget was to risk being caught unprepared when the waters rose again. The question is not whether catastrophes happened. The geological record confirms they did. The question is what was lost. Because the survivors of such events do not emerge with their civilizations intact. They emerge traumatized, scattered, regressed. Complex societies depend on networks, trade, specialization, writing, centralized infrastructure. When the cities drown, when the trade routes collapse, when the scribes die and the libraries burn, the survivors revert. Not because they are less intelligent, but because survival demands simplicity. You cannot maintain a Bronze Age economy when your mines are underwater and your traders are dead. You cannot preserve advanced astronomy when your observatories are rubble and your star charts are ash. You cannot continue philosophy, literature, mathematics when every waking moment is spent hunting, foraging, and fleeing. This is why advanced societies can vanish leaving almost no trace. Because the catastrophes that destroy them are precisely the kinds of events that erase evidence. Floods bury, fires consume, earthquakes shatter, ice sheets grind bedrock to powder, and the survivors, reduced to subsistence, cannot maintain the material culture of their ancestors. Within a generation, the old world becomes legend. Within 3, it becomes myth. Within 10, it is forgotten entirely, except as a feeling, a distant haunting sense that we once knew more, that the gods once walked among us, that there was a golden age before the darkness. And so, the cycle begins again. Slowly, painfully, humanity rebuilds. Agriculture is re-established. Villages grow into towns, towns into cities. Writing is rediscovered or reinvented. The stars are charted again. Mathematics, metallurgy, architecture, all the arts of civilization gradually recovered, but not invented. Recovered. Because the knowledge was always there, waiting in the ruins, encoded in the stones, whispered in the old songs, preserved by the few who remembered that the world had ended once, and that it could end again. The geological layers tell the same story the myths do. Boundaries marked by ash, by impact debris, by sudden extinctions. The KT boundary, 66 million years ago, where the dinosaurs vanished in the blink of an eye. The Permian-Triassic boundary, 252 million years ago, where 90% of all species died, and scattered through the Holocene, smaller boundaries, localized catastrophes that ended not all life, but specific ways of living, civilizations. Perhaps that is the real terror of the cataclysm, not that it happened once, but that it keeps happening, that Earth is not a stable platform, but a dynamic, violent system punctuated by events that reset the human story over and over. And each time we forget a little more. Each time we lose a little more. Until all that remains is the myth, the memory, and the unshakable sense that we are not the first to walk this path, that others came before, built wonders, reached heights we can barely imagine, and then vanished, swept away by fire, water, ice, or sky, and that we, for all our technology and confidence, are no safer than they were. We are simply living in the interval between catastrophes, in the quiet moment before the sky falls again. Every culture on Earth tells the same story. The details shift, the names change, the geography varies, but the core narrative remains constant, unshakable, preserved across millennia with a consistency that defies coincidence. There was a time before, a golden age, a world of wisdom and abundance, and then came the water, the fire, the cataclysm. The old world drowned, and from the ruins, strange teachers emerged, beings who came from the sea, from the sky, from somewhere else, bringing the knowledge needed to rebuild. They taught agriculture, astronomy, architecture, law. They established kingship and priesthood. They gave humanity the tools to begin again. And then they left, ascending back to wherever they came from, leaving behind only memory, myth, and monuments. Mainstream scholars call these stories mythology, symbolic, archetypal, metaphorical. Expressions of humanity's psychological need for origin narratives, collective anxieties about nature's destructive power, poetic attempts to explain the inexplicable. And perhaps they are right. Perhaps every flood myth, every story of golden ages lost and divine teachers descending, is merely the human imagination spinning meaning from chaos. But the alternative is more unsettling. What if these stories are not inventions? What if they are recollections? Fragmented, distorted by time and translation, but fundamentally real. What if the reason every culture remembers the same events is because those events actually happened? What if the gods were real? Consider Plato. In 360 BCE, In two dialogues, the Timaeus and Critias, he described a civilization called Atlantis, an island empire beyond the Pillars of Hercules, in the Atlantic Ocean, advanced beyond measure, with sophisticated engineering, monumental architecture, and naval power that dominated the Mediterranean. According to the account, Atlantis existed 9,000 years before Plato's time, roughly 11,000 years ago. It was destroyed in a single day and night of catastrophic earthquakes and floods, sinking beneath the sea, vanishing so completely that only legend remained. For centuries, scholars dismissed Atlantis as allegory, Plato's philosophical fiction, a cautionary tale about hubris and imperial overreach. But Plato insisted repeatedly that the story was true, handed down from Solon, the Athenian lawmaker who heard it from Egyptian priests at Sais. The priests told Solon that their records stretched back thousands of years, far beyond anything the Greeks remembered. And within those records was the memory of Atlantis, a great civilization that fell before history began. Was Plato inventing, or was he repeating? The Egyptian priests claimed their knowledge came from stone inscriptions predating the flood. If those records existed, and if they described a real civilization lost to cataclysm, then Atlantis is not fantasy. It is cultural memory, a preserved fragment of something that truly happened. And if Atlantis was real, it was not alone. Because the flood stories do not stop with Plato. They saturate human mythology, appearing in nearly every ancient culture across every continent. The Epic of Gilgamesh, recorded in Akkadian cuneiform around 2100 BCE, but based on older Sumerian sources, describes Utnapishtim, the man who survived the deluge, by building a massive boat sealed with pitch. He loaded it with animals, craftsmen, and seeds, and rode out the storm while the world drowned. When the waters receded, Utnapishtim sent out birds to search for land, a raven, then a dove, then a swallow. The story is so similar to the biblical account of Noah that scholars initially thought one had been copied from the other, but the Sumerian version predates Genesis by over 1,000 years. Both are describing the same event, filtered through different languages, different theologies, but the same core memory. In Hindu tradition, the flood survivor is Manu. The Matsya Purana tells how Vishnu appeared to Manu as a fish, warning him of an impending deluge that would destroy all life. Manu built a ship, gathered seeds and sages, and survived the flood. When the waters subsided, Manu became the progenitor of the new human race, the first man of the new world. In China, the legend of Gun Yu describes a great flood that covered the mountains and drowned the plains. The hero Yu spent decades channeling rivers and draining floodwaters, reshaping the land itself to make it habitable again. In Greece, Deucalion and his wife Pyrrha survived the flood sent by Zeus to cleanse the earth of human corruption. In Norse mythology, the world drowned in the blood of the giant Ymir before the gods reshaped it. In Mayan tradition, the Popol Vuh describes multiple cycles of creation and destruction, worlds unmade by flood and fire before the present age began. The list goes on. Indigenous Australian cultures speak of a time when the seas rose and swallowed the coasts. Pacific island traditions describe entire landmasses lost beneath the waves. Native American tribes from the Ojibwe to the Hopi preserve stories of a previous world destroyed by water. More than 200 flood myths have been catalogued across human cultures. 200 separate traditions, geographically isolated, linguistically unrelated, all preserving the same story. How? The conventional answer is that floods are common. Rivers overflow, coasts erode, tsunamis strike. Every civilization experiences flooding at some point, and so every civilization develops flood myths. But this explanation does not account for the consistency. These are not local floods. They are global cataclysms, waters that cover mountains, events that destroy the entire world. And in nearly every version, the flood marks a boundary. There was a world before and a world after, and the world before was better. The Greeks called it the Golden Age, a time when gods and mortals lived together, when the earth provided abundance without labour, when death was gentle, like falling asleep. The Hindus called it Satya Yuga, the age of truth, when humanity lived for thousands of years in peace and spiritual perfection. The Egyptians spoke of Zep Tepi, the first time, when the gods ruled directly over the land. The Sumerians remembered a time before the flood, when the Anunnaki walked among men, when the sacred me, the codes of civilization, were fully intact. The Chinese spoke of the reign of the sage emperors, divine rulers who taught humanity medicine, agriculture, and writing. In Persia, it was the reign of Yima, the perfect king who ruled in an earthly paradise free from disease and death. The Aztecs called it the first sun, the age before the world was destroyed and remade. This memory, this ache for a lost golden age, saturates human mythology. Every culture looks backward towards something better, something forgotten, and they all place it before the flood. Why? If these stories are merely psychological, why do they all agree on the timeline? Why does every tradition place the fall, the loss, the catastrophe at roughly the same point in the distant past? Perhaps because they are not inventing, perhaps because they are remembering. And if they are remembering a world before, what do they remember about the beings who survived it? The stories are strikingly consistent. After the flood, teachers arrived, wise figures emerging from the sea, descending from the sky, appearing from distant mountains or foreign lands. They came to the survivors, the scattered remnants of humanity, and they taught. They brought knowledge that had been lost, knowledge too advanced to have been developed by Stone Age flood survivors struggling to rebuild. And yet, there it was, embedded in the earliest civilizations, complete and operational from the start. In Mesopotamia, the Sumerians spoke of the Apkallu, 7 sages who came before the flood and who returned after, emerging from the waters of the Persian Gulf. They were described as fish-garbed, wearing cloaks that shimmered like scales, carrying the me, the divine knowledge of civilization. The Apkallu taught writing, law, astronomy, architecture, and medicine. They were sent by Enki, the god of wisdom, to preserve humanity from ignorance. In Egypt, the priests at Heliopolis spoke of the Shemsu Hor, the followers of Horus, divine beings who ruled Egypt in the time before history, before the dynasties, before the pharaohs. They built the first temples, aligned them to the stars, and passed down the knowledge that would later become the foundation of Egyptian science and religion. In Mesoamerica, the Maya and Aztec remembered Quetzalcoatl, the feathered serpent, a god-king who came from across the sea, bringing maize, astronomy, and the sacred calendar. He was described as bearded, fair-skinned, wearing robes, not native to the land. He taught civilization, then departed, promising to return. In South America, the Inca spoke of Viracocha, the creator god who walked among men after the flood, teaching agriculture and stone masonry. He travelled across the Andes, raising up temples and shaping mountains, before walking westward across the Pacific, vanishing into the sea. In India, the rishis, the ancient sages, were said to possess knowledge not learned but remembered, passed down from the time of the gods, from before the flood. They composed the Vedas, texts so old their origins are lost to time, filled with cosmology, astronomy and mathematics that scholars still struggle to fully decode. In China, the 3 sovereigns and 5 emperors were described as semi-divine, possessing knowledge of heaven and earth. They taught writing, medicine, agriculture and governance, then ascended back to the celestial realm. In Polynesia, the god Maui was said to have fished up islands from the ocean floor, taught navigation by the stars, and gave humanity fire. He was a trickster, a teacher, a bridge between the divine and the mortal. The pattern repeats, across oceans and centuries, separated by vast distances and mutually unintelligible languages. The story is the same. After the catastrophe, mysterious teachers appeared. They came from the water or the sky. They brought knowledge. They rebuilt civilization. And then they left. Were these gods, or were they survivors? Remnants of a pre-flood world, an advanced civilization that possessed knowledge far beyond what Stone Age tribes could comprehend. Imagine you are a hunter-gatherer, struggling to survive in the aftermath of a global cataclysm. The world has been scoured, the coasts have shifted, the climate has changed, and then, from across the sea, ships arrive. Not crude rafts, but actual ships, with sails, with navigation. And aboard them are people who know things. They know how to smelt metal, how to track the stars, how to channel water, how to write. To you, they would seem divine. And if they wore strange clothes, spoke a different language, possessed tools you had never seen, you would describe them the only way you could. As gods. As beings from another realm. Perhaps that is what the myths are preserving. Not metaphor, not allegory, but memory distorted by time and incomprehension. The memory of an older humanity, more advanced, more knowledgeable, who survived the flood and emerged to teach those who did not. And if that is true, then the Golden Age myths are not fantasies of perfection. They are recollections. Faint, distorted, but real. Memories of a time before the catastrophe, when the world was whole, when knowledge was intact, when civilization had reached heights we are only now beginning to rediscover. The flood destroyed that world, but it did not erase it. Fragments survived in myth, in ritual, in the teachings passed down by those mysterious figures who came from the sea. But there are stranger echoes still. The myths do not only speak of floods and teachers, they speak of battles in the sky, gods warring in heaven, stars falling, mountains shaking, the firmament itself torn apart. The Norse Ragnarok, the Hindu war of the Mahabharata, the Greek Titanomachy, the biblical war in heaven, Revelation's dragon cast down to earth. These stories are not quiet. They are violent, cataclysmic, cosmic in scale. They describe events that shake the foundations of reality itself. For centuries, scholars interpreted these as symbolic, good versus evil, order versus chaos, the eternal struggle. But what if they were descriptive? What if ancient peoples witnessed something in the sky so terrifying, so beyond comprehension, that they could only describe it as war among gods? Cometary impacts, meteor storms, supernovae, plasma discharges in the upper atmosphere during geomagnetic storms, events that lit up the sky, that roared like thunder, that seemed to tear the heavens apart. To a pre-scientific culture, these would not be natural phenomena. They would be divine warfare, the gods themselves locked in battle, and humanity caught beneath the fallout. The myths also speak of giants, beings larger than men, stronger, longer lived. The Nephilim of Genesis, born when the sons of God mated with the daughters of men. The Titans of Greece, the first generation of gods, enormous and powerful. The Jotnar of Norse myth, giants who oppose the gods. The Anakim and Rephaim of Hebrew scripture, races of giants who once inhabited Canaan. The Quinametsin of Aztec legend, the people of the previous sun, towering beings who built the pyramids. Why does every culture remember giants? The conventional explanation is exaggeration, mythologization of enemies, symbolic representations of primal chaos. But skeletal remains have been found. Fragmentary, controversial, often dismissed. But they exist. Homo heidelbergensis, Homo neanderthalensis, Denisovans, other human species, larger, more robust, who coexisted with Homo sapiens and then vanished. What if the myths of giants are not inventions? What if they are memories of other human species, cousins we once shared the world with, who were absorbed, outcompeted, or destroyed in the cataclysms that reshaped the earth? And if those other species possessed knowledge, culture, technology, then their loss was not just biological, it was civilizational. Another fragment of the world before, erased but not forgotten, lingering in myth as the age of giants. And then there is the serpent, the symbol that winds through every mythology, every tradition, every sacred text. In Sumer, the serpent guarded the tree of life in the garden of the gods. In Genesis, the serpent brought knowledge, forbidden fruit, the awakening of consciousness. In Egypt, the Uraeus serpent crowned the pharaohs, symbol of divine authority and protection. In Mesoamerica, Quetzalcoatl, the feathered serpent, brought civilization. In India, the Nagas, serpent beings, guarded sacred knowledge and treasures beneath the earth. In China, the dragon, serpentine and wise, represented cosmic power and imperial legitimacy. In Greece, the serpent coiled around the staff of Asclepius symbolized healing and medicine. Why the serpent? Why always the serpent associated with wisdom, with transformation, with hidden knowledge? Some researchers suggest it is biological, the serpent as predator, ancient threat encoded in our primate brain. But the mythological serpent is not a threat. It is a teacher. It is the keeper of secrets, the guardian of thresholds. It is the force that grants knowledge at a cost, that awakens humanity from ignorance, that catalyzes transformation. Perhaps the serpent is symbolic, or perhaps it is mnemonic, a way of encoding and preserving information across generations when writing did not yet exist. The serpent as symbol of continuity, of cycles, of knowledge that sheds its skin and renews itself. The ancient wisdom keepers, the mystery schools, the initiates into sacred knowledge, they are always associated with the serpent, because the serpent represents what they protect. The knowledge from before, the teachings of the world that drowned, and that knowledge, according to indigenous traditions worldwide, was not primitive. The Aboriginal Australians speak of the dream time, when the ancestors walked the earth shaping the land, singing the world into existence. Those ancestors possessed deep knowledge, ecological, astronomical, spiritual, encoded in songlines that map the continent with precision. The Native American tribes speak of star people, ancestors who came from the sky, who taught ceremony and medicine. The Dogon people of Mali preserve astronomical knowledge about Sirius B, a white dwarf star invisible to the naked eye, yet described in their oral traditions with accuracy that baffles astronomers. The Maori of New Zealand recount migrations across vast Pacific distances, navigated by stars and currents, feats of seamanship that modern sailors struggle to replicate. These were not primitive peoples stumbling through the dark. They were inheritors of knowledge, carriers of traditions stretching back to a time when the world was different, when the ancestors, whoever they were, knew more than we have given them credit for. The myths are not children's stories. They are archives, encoded in symbol, repeated in ritual, preserved through oral tradition across thousands of years. They are humanity's oldest hard drive, the backup system for civilization, designed to survive catastrophe. And what they preserve is this: there was a world before, it was destroyed, and something survived. Knowledge survived, teachers survived, memory survived, distorted, fragmented, mythologized, but real. The gods were real, not as supernatural beings perhaps, but as something we have forgotten. Advanced ancestors, lost civilizations, survivors of the deluge, beings whose knowledge seemed divine because we had fallen so far that we could no longer comprehend it. And they taught us. They gave us the tools to begin again. And then they faded into legend, leaving only the myths, the monuments, and the haunting certainty that we are not the first. So what are we to make of it all? The stone temples that predate agriculture, the genetic bottlenecks that whisper of mass extinction, the impossible precision of monuments aligned to stars that hadn't risen in 100,000 years, the flood myths repeated across every inhabited continent, the traces of metallurgy in layers too old to contain them, the architectural knowledge that appears suddenly, already perfected, as though downloaded rather than developed. The evidence does not give us certainty, it gives us something far more unsettling: possibility. The possibility that everything we've been taught about the timeline of human civilization is wrong. Not slightly wrong, fundamentally, catastrophically wrong. The possibility that we are not the first to rise, that this cycle of civilization, this climb from darkness into light, from ignorance into knowledge, has happened before, perhaps many times, and that each time, almost everything was lost. Mainstream archaeology tells us that civilization began around 6,000 years ago in Mesopotamia. Cities, writing, agriculture, all emerging together in a sudden flowering of human achievement. But the deeper we dig, the older the anomalies become. Göbekli Tepe, 11,600 years old. The Sphinx water erosion, possibly far older. Genetic evidence of population collapse 70,000 years ago. Tool technologies that vanish and reappear across impossible time spans. And beneath it all, the myths. The stories that refuse to be dismissed. Stories of golden ages, of builder gods, of worlds that drowned, of knowledge that was given, not earned. What if those stories are not metaphor? What if they are memory? Distorted by time, fragmented by catastrophe, but memory nonetheless. The kind of memory that survivors carry when everything else has been taken from them. When the libraries have burned, when the cities have collapsed into the sea, when the very names of the gods have been forgotten. What remains is the story. And the story says, we were greater once. We knew more. We built higher. And then the world ended, and we had to begin again. This is not a comfortable realization. It strips away the myth of progress, the idea that history moves in a straight line from primitive to advanced, from ignorance to enlightenment. It suggests instead that history is cyclical, that civilizations rise, flourish, and fall. That knowledge is not accumulated steadily, but lost and rediscovered. That we are not the pinnacle of human achievement. We are simply the latest attempt. And if we are not the first, we will not be the last. Someday, perhaps sooner than we think, our own cities will be ruins. Our technologies will be mysteries, Our monuments will provoke the same questions we now ask of those who came before. Future archaeologists will sift through our rubble and wonder, how did they know? How did they build? Where did they go? But here is the hope buried in that humbling truth. If civilizations have risen before, if knowledge has been lost and recovered, then humanity is more resilient than we imagine. We have survived ice ages, floods, volcanic winters, genetic bottlenecks that reduced us to a few thousand souls clinging to existence. And each time we came back, each time we rebuilt, each time we reached again for the stars. New evidence emerges constantly, ground-penetrating radar revealing structures beneath the sand, genetic studies uncovering forgotten migrations, satellite imagery exposing patterns invisible from the ground. We are standing at the edge of a revelation. The timeline is breaking. The story is rewriting itself, and we are here to witness it. So as you drift into sleep tonight, let your mind wander through deep time. Imagine the forgotten world that existed 100,000 years ago. The civilizations that rose and fell in the vast silence before recorded history. The knowledge they possessed, the monuments they raised, the memories they tried desperately to preserve. We are their descendants. We carry their DNA. And somewhere, encoded in stone, in myth, in the very structure of our cells, their story waits to be remembered. We have only begun to listen.